Yeah, good morning, guys. Welcome to the session. Mm, So let's wait for another 10 minutes. Let everyone join the session. You can see very less count here. Then we'll start, okay? Yeah, guys, people are still joining. So let's wait for another 8 minutes. Then we'll start the session. Yeah, guys, I see students are still joining. Let's wait for another 5 minutes. Then we'll start the session, okay? Yeah, welcome guys. In the next 5 minutes, we'll start the class, okay? Students are still joining, so let's wait for them.
Good afternoon, guys, and I hope everyone joined. So, what are we discussing yesterday? I mean, in the last session, what are we discussing, guys? Let me know in the Q&A what are we discussing, and I hope you people are clear with all the topics which we are discussing. If anyone is having doubts on any of the topic, you can post it over here. Just give me a moment. Let me just share the PPT. In the last session, we are done with the prompt. We were about to complete the prompt engineering, right? So we'll complete that now. Just a moment. So can anyone let me know what are the key principles of prompting? What are the key principles? In the last session we were discussing, right? All the principles and all techniques, principles, different types of prompting, different techniques. Remember, guys? So where are we? So we're not yet here, right? So we're done with the case one analysis, right? Case one study we are done, right? The case study one we are done. Case chain of thought was done. Real world role playing. Even role playing, are we done with the role playing? Up to here it's done. So let's continue with the role playing once again. So what are the key principles of prompting again? First, we need to maintain some clarity, right? So clarity is one of the main key principles. And then we need to provide some context over there. Context is nothing but the background information, correct? So we need to provide some background information also. Then after, what is another other important thing, other important key principle? Clarity, context, and also specificity. We need to specify what exactly we are trying to get right. So everyone understood, right? All those three main key principles. After that, what did we discuss? We have discussed about the types of prompting, right? What are the different types of promptings available? It's one shot, two shot, few shot, chain of thought prompting. So these are some of the prompt techniques, right? These are some of the prompt techniques which we have discussed, correct? Remember all this? Remember or else? Okay, fine. So let me just continue with the PPT, okay? Just give me a moment. We were unable to see that. I'm sharing the screen once again. Okay, role playing. What is role playing and how exactly we can work on this role playing? So role playing is what? It is about instructing the LLM act like a specific person or a specific persona or else a particular role. Just like how we give a system user prompt. Remember system user prompt? So we'll be giving that system prompt, right? Based on the system prompt only, the LLM will react, correct? Based on the system prompt, the LLM will try to react and according to that only it will be generating the response because we are telling the LLM to act as that way and then let me know what are all the things I need to perform or else I need to do according to that particular query that we are trying to solve. So what is this mechanism? It involves defining the LLM's background, expertise, and communication style. Okay. So mechanism what are the things involved in this role playing means it involves defining the LLM background, expertise, in what kind of LLM expertise it is. So it's like some LLMs are better at code generation. Some LLMs are better at textual interaction, like a chatbot interaction or else query question answering interaction. Some LLMs are better at logical thinking. So an example to consider for this logical thinking is you can consider DeepSeek. Initially, when DeepSeek was launched around in January to February, it got much fame, and like most of the people recognized what exactly DeepSeek is doing, how exactly DeepSeek is working. Have you ever tried or else have you ever heard of this DeepSeek? Anyone? DeepSeek and also Claude, Anthropic Claude 3.5 Sonnet, or else Gemini model. Gemini models, you all know, right? Gemini models, you all know. Okay, fine. See, no one ever heard of that model. Fine. So now I'll just introduce you to this LLM, that is DeepSeek. How DeepSeek exactly works is, whatever the query you are asking, like let's say you are asking what is prompt engineering. Okay, what is prompt engineering you have asked. So now how LLM reacts is, LLM will make sure that LLM will make sure that it will first understand what is the query asked by the user. What is the query asked by the user? Then it will start the logical thinking process. How it is decoding our query, it will be showing all the process. So how that will be appearing is, so now the user has asked about this prompt engineering. So I need to figure out first what is prompt and what is engineering. So then it will first understand what is prompt. Prompt is a query or else an input text which is asked by the end user, and the LLM will be responding to it. And then what is engineering? How this combination of prompt and engineering will help us to generate the output. Okay, it will try to think everything in a logical manner and then it will show the output. Let me just show you an example for that. Okay, just a minute. Let me just log into this. It is asking for login. Once it is logged in, and I'll show you. Okay, asking for sign up. Signing in. Yeah, I'm sharing my screen. Just see how DeepSeek will think in a logical manner. Just see. So this is DeepSeek interface. Okay, all you need to do is you just need to sign up and sign in. Okay, sign up and sign in. So now you see, let me just give what is the same example. I'll give what is prompt engineering. Okay, now let's give this query. Okay, it is not showing its thinking. Just it didn't show that it is thinking. Just a minute. I need to apply the deep think. Okay, just a minute. This prompt engineering. Which tells him. See, if you see, okay, the user is asking about prompt engineering, and let me just click on continue. Just see. Okay, the user is asking about prompt engineering. This seems like a straightforward definition, but I should consider why they are asking. Maybe they are new to AI. See how it is reasoning the things based on the simple question that you are asking. How it is reasoning. Perhaps they are trying to improve their interactions with the chatbot. Engineering is a hot topic since LLMs became mainstream, and also the user might be a developer, a curious individual, or even a student. See how it so mainly if an end user is asking about prompt engineering, this LLM is logically dividing that end users into three different categories: individual, student, and a developer. Correct. And since they didn't specify, I'll keep it as general but precise. So, and then it has reason like, first what I need to do, I need to explain it simply, crafting the inputs to get the better outputs from AI. Okay, this is about the prompt engineering, correct? So then it is also giving that if you say giving clear instructions to very literal but super smart assistant should cover the key aspects. Why does it matter? Core techniques, real world uses, and also see how it is reasoning each and everything, how it is thinking. After thinking, it has generated these outputs. Once you go through this output, it is saying that is the practice of designing and refining the input given to a large language model or other generative AI system to get the desired output reliably and efficiently. It's like learning how to talk to the AI effectively to unlock its best performance. See the breakdown of what it involves and why it's important. Core idea, why it is needed. See, all this thing is related to prompt engineering. But did you see how it is thinking? How it is thinking you have seen, right? So now let me share the PPT again. So these are the different kinds of LLM. One LLM is good at logical thinking. Another LLM is good at code generation. Another LLM is good at generating the images. So it depends. So LLM background and that LLM is expertise in which kind of area. Okay. And the communication style, how it is communicating. All these are the important mechanisms we need to consider. Okay. We need to consider. Then some of the use cases are over here. So customer service simulation. So you are a friendly and a helpful customer support agent. Technical explanation. There is some technical explanation also. You are a seasoned software engineer explaining a complex algorithm. So this is related to technical explanation. Creative writing. So you are a famous science fiction author writing a short story. So even to generate the essay kind of text also, there were some specific LLMs to do that work. Okay. There are some specific LLMs. So what are the benefits for this role playing? It will make sure it will tailor the LLM output to the specific needs and also expectations of the user. Can improve engagement and credibility and the ethical consideration also it will do. So now we'll do a role, we'll see one role playing example, okay? We'll see one role playing example. Or else let me just share my full screen, it will be better. We are switching in between the screens, right? Okay. So I hope everyone is able to see my screen now. Fine. So we are done with this prompt engineering, right? So what I will do, the role is, okay, consider yourself as an prompt engineer. Consider yourself as a prompt engineer, or else consider yourself as an A. Not consider. We can mention like role play. Role play also we can mention. So you are an AI expert, where an AI expert answers every query related to Gen AI. Okay. Now user query will be, we can mention as system role. Okay. What is, so let's say what is Gen AI, okay? Or else let me just give what is GANs. We have already discussed GANs, right? So we'll give GANs and let's verify the content. Let's see. Okay, so now how it is thinking, okay, the user wants a role play scenario where I am positioned as an AI expert specialized in Gen AI, and the specific question is what is GANs. So again, it will start the logical reasoning. Okay, logical reasoning it will be starting. And if you see AI expert model, system role is generative AI specialist. So as a generative AI specialist, now it is telling about the GANs. So invented by Ian Goodfellow in 2014, designed to generate new synthetic data, which mimics the real world data. And there's this core idea also. dual agent game, and generator discriminator, output probability, starts with the random noise, training was discriminator, generator, key applications, challenges. So this is one of the example of how we can consider this role play kind of a technique. Okay. Even also now you can do this one-shot prompting also you can consider, or else you can consider two-shot prompting, or you can consider chain of thought prompting also. But it should be relatable to that particular scenario that you are, or else particular domain that which you are trying to learn. Okay. And I hope it's fine. These are all some of the use cases. So if you want to do, I can give this as a role play. You are a famous science fiction author, write a short story. Now I'll give a short story concept I can do. So you can just write a creative story. Okay. So this is about role playing. Some real world applications. So what it is saying activates specific parts of the LLM knowledge base and influence its language generation patterns. So what is the example here? Prompt and the expected output. What is prompt? You are a world renowned historian specializing in ancient Rome. Explain the cause of the Punic Wars. I think we are done with the Punic Wars, right? Fine. So expected output will respond with the detailed historical information, accurate terminology, and a scholarly tone appropriate for historian. So it will generate the output similarly how a historian will be generating. In that format only it will generate the output. So that is one kind of an application. Then the case study. Case study about the code generation case study. This is writing a function to calculate the factorial of a number. So that is very too ineffective. It will just generate the code uh, which is related to this factorial function, but it will generate in multiple languages. But if I specify to follow the Peptide style, and if I give some background context also, then it will generate the code in a well documented manner. So this is one of the case study. And analysis, just go through this analysis once. What it is saying, effective prompt provides crucial details about the desired language, input type, error handling, documentation, styling, leading to a significantly better outcome. So using coding frameworks like Peptide style Wave. So these are some of the coding frameworks also which we can use: Amazon Code Whisper, Tab9, GitHub Copilot. GitHub Copilot we can see in our VS Codes also. Let me just open my VS Code. So in the VS Code, if you see here, okay, I hope everyone is able to see. Now, if you see over here on the top bar, this is a Copilot. Okay, this is a GitHub Copilot. Ask the Copilot. We can switch the models here, and we can also ask agent edit. So these are all the different filters we can apply. If you want to add a context, we can upload the file, or else whatever the file which is open over here in the editor, it will consider that file. So GitHub Copilot will be helpful in code also. Okay. So that is the Copilot for VS Code. Okay. So it will be similar. Fine. And case study 2 is summarization. So what is an effective and an ineffective prompt for summarization? We'll see. So an effective prompt for summarization is nothing but we'll just mention summarize the article. But we are not mentioning clearly, and we are not being very specific, and also we are not providing the context over there. So it will not be able to understand what particular domain we are referring to, correct? But we'll be pasting that long complete article. So based on the complete article, it will just give the summarization. That's it. So how it will be generating the output, how the output will be a brief generic summary, which is lacking focus and also potentially missing the key information. Because I'm just telling the LLM to just consider the text block, and then summarize that whole text. But I'm not being very specific what kind of information I need, or else what kind of information is useful from that particular document. I'm not being very specific to that. So that is why it will generate a brief generic summary. But see the effective prompt. Summarize this quarterly earnings report in 200 words or less for senior management, focusing on the key financial metrics like revenue growth, profit, margin, profit margins, and customer acquisition cost. Highlight, sorry, highlight any significant deviations from the previous quarters. See how the effective prompt it is. So now, if I just upload that quarterly earnings report and if I just say summarize this article, I'll be just seeing a plain simple response of summarize the format of that particular article. But if I give the prompt in this particular format, LLM will make sure that the report is in 200 words or less, and which is mainly focusing on the key factors which the senior management will be focusing on, like the metrics, revenue growth, profit margins, customer acquisition cost. So all these factors, these three main factors, it will consider, and it will consider the senior management focus. Then it will generate the report within less than 200 or less than 200 words. And if there is any significant deviation happening from the previous quarters, it will just make sure that all those things are mentioned over here. Okay. So how the output will be for that particular effective prompt? It will be very precise and concise and informative, which is specifically addressing the economic impact, stakeholders, and the reactions as instructed. So this is one kind of case study, okay? One kind of case study. Even if you are having any PDF and you just know that PDF is related to that particular domain, but you just want to know few factors which are present in that particular PDF, then you can go with this particular prompt, okay? Then you can go with this particular prompt. Let's say for example, I'm having a PDF which is related to GenAI, okay? GenAI. So now what I will do is I just upload that particular GenAI PDF and I'll just give the prompt as summarize this GenAI PDF in less than 200 words and also focus on the key concepts which were mentioned in this PDF. Okay. And highlight any significant deviations or else highlight any important factors or else ethical considerations from this particular PDF I will give. So it will just make sure that all these points were mainly covered and it will try generate a neat and clean summarized output from the whole PDF. So what is the key important factor here? What is the key important factor here? First thing is we are maintaining a clarity, correct? We are maintaining clarity and we are being very specific. We are being very specific. And then what are we doing? Then we are providing some context, correct? So all these three factors together is nothing but prompt engineering again, correct? So key principles are very important and techniques are just the add-ons which we need to learn in the prompt engineering. So business impact. So let's see for the business impact how it is saying. In this scenario, an effective summarization prompt saves senior management valuable time by providing a concise overview of key financial performance indicators, enabling faster decision making. So for this particular effective prompt which we have given, so this is how the business impact will be. The whole document, it will be generating some summary, which will make sure that it is having all these financial performance management indicators, and also it will also save the senior management time by providing the concise overview. Okay, so this is how it could make an impact, because by the end of the day, or else by the end of the day, whatever the things which we are learning, how we are implementing it and how it is going to affect in our real world application is matters, correct? That is what the important factor is. So this is one of the business impact, correct? By the end of the day, how that particular tool or else particular technology is impacting your business, right? If you are using some particular technology in your business, how it is going to bring an impact? That is what we will be checking, right? So this is how it could make an impact. So iterative prompt refinement. So this is one of the techniques. So what is the process over here? Initial prompt, evaluation, refinement, testing, and repeat. So instead of going through each and every point, just go through the side headings first. The headings first. Initial prompt. Initially, there will be a prompt. Evaluation. So we'll do the evaluation. Then If there is an improvement needed, we'll do the refinement and we'll test it again and we'll continue the process again, repeat. So it's like continuous iteration, correct? Until what, I mean, until what continuous iteration is happening until what? Until our desired output or else until our expected output is achieved or not, correct? Initial prompt is start with the basic prompt based on your understanding of the task, then evaluate that. Evaluation is analyze the LLM's output, identify areas for improvement. What could be the areas for improvement? It could be related to some style, I mean, in the format how you are giving the prompt, or else it could be some relevancy issue. It could be related to some accuracy. We will do the evaluation, then we'll do the prompt refinement. Prompt refinement. So modify the prompt based on the evaluation, add the constraints or else clarify the instructions, and provide more context. Correct. Context is the main important factor here. If you're not providing enough context, it will not understanding what we are trying to, I mean, what we are expecting from the LLM. So it will generate some random content or else irrelevant content that which it has understood based on our prompt. So in that place, I mean, in that case, refinement is compulsory. So refinement will be done. Then again, we'll test that particular prompt and we'll rerun the LLM with the refined prompt. And again, we'll repeat until we get a desired output. So once we got the desired output, so that is the prompt which we are actually struggling to get our desired output. So it's all like how we are making sure that you are getting your output. So this is one of the technique, iterative prompting. Give a prompt, evaluate it, refine it, retest it again. So repeat the process until you get that output. Okay. And what are some tools? What are some tools? So what it is related to tools? What it is saying? Prompt version control, evaluation metrics, A and B testing. So we'll just go through each and every one. I mean each and every concept. Like prompt version control. What it is saying? Prompt version control. See, version control means we all know to handle the code, Git and GitHub we are having, Git version controls we are having. So in a similar way, there is this prompt version control that is tracking the changes to prompts to identify what works best. Got it? See, this is very important again, prompt version control. You will understand everything clearly, but there is one small tweak over here. That is what which you need to understand, okay? Tracking the changes to prompts to identify what works best. So let's say I'm working on an application, okay? I'm working on an application or else a code file. Okay. Now, I want to implement 2 to 3 functionalities, but by the prompt which I am giving, I'm getting only one functionality, but the other 2 functionalities are failing. Okay, other 2 functionalities are not working properly. So now I'll change the prompt and I'll refine the prompt and I'll just make sure that the other functions are working. But what happens? The previous function may be having some error due to the variable calling or else other errors we'll be getting, correct? Mostly due to the variable calling errors only or else not calling the proper function over there. So we'll be getting that error, correct? Not defining the things. So that is one kind of error I may face. But what happens here? The second functionality is running. So similarly, if I refine the prompt, maybe the third functionality could run, but I may get error in first and second. So in order to make sure that whatever the prompt which I'm using in this all 3 functionalities, I just need to combine all those prompts or else I need to combine those prompts and I need to refine my prompt, making sure that all the 3 functionalities are working well and good. So I need to track each and every prompt. So to track each and every prompt, there is this prompt version control, okay? Prompt version control, which will track the changes to prompts to identify what works best. Okay. And evaluation metrics. What is this evaluation metrics? It will use the quantitative metrics like ROG or else, yeah, ROG for summarization, and there is also blue score to access the performance. Okay. A&B testing. A&B testing is nothing but comparing the performance of the different prompts. Okay. Collaboration tools. What are the collaboration tools? So platforms like Notion, Google Docs, and dedicated prompt engineering tools allow teams to collaborate on prompt creation, share the feedback, and track the progress. So what are the prompt? So let's say there are a group of developers and they were working on an application. So whatever the prompts they were working with, and which are giving the desired output, they'll just make sure that they were tracking that particular progress. Okay, and we are having these collaboration tools for that. So platforms like Notion and Google Docs will help us. And importance, what exactly the importance is? Prompt engineering is not a one-time effort. It's an ongoing process of refinement and optimization. Correct. So even now you have learned this prompt engineering, right? So now if you are going to test this prompt engineering techniques on a specific topic, you will be giving this one shot and two shot prompting, correct? So immediately you may not get the result that you are expecting. By refining the prompt, you'll get the desired output. Okay. Some of the advanced techniques. So what are some of the advanced techniques which are present? Automatic prompt optimization using algorithms to automatically generate and refine the prompts. So what it is saying, what are some advanced techniques? Automating the prompt optimization. How to optimize, how to optimize the automatic prompt using the algorithms to generate and refine the prompts. Okay, we'll use some algorithms to generate and also refine those particular prompts. So what are those techniques again? Prompt chaining, retrieval augmented generation, knowledge graph integration, vector database lookup, and prompt ensemble. So what is this prompt chaining again? Breaking down the complex tasks into series of prompts. Okay. So let's say I need to work on an application. Prompt chaining example I'm saying. I need to work on an application where I need to implement multiple pages and multiple services in those pages. So first I will just make sure that I'm dividing this task into subtasks, and then I'm working on it, correct? So in a similar way, the whole big prompt which I'm planning, I'll divide the things into sub prompts that will give each and every subtopic prompt in a stepwise manner, and I will try to generate the whole output as per those subtopics. Okay, so that is what the prompt chaining is. And there is this retrieval augmented generation. What is retrieval augmented generation? This is important to me. Integrating external knowledge sources into prompting process. Okay, prompting process. Integrating the external knowledge sources into prompting process. RAG is very important, and nowadays there are different types of RAG techniques also. Once you are done with this prompt engineering, we'll go through RAG. Okay, we'll go through RAG. Fine. So knowledge graph integration. What did he say? Enriching the prompts with information retrieved from knowledge graphs to improve accuracy and context. Okay. Vector database lookup. Vector databases are the databases which are storing the information in the format of a vector. Correct. So some of the vector databases are Pinecone, ChromaDB. They will be helpful to retrieve the relevant document based on the semantic similarity search. Okay, semantic similarity search. And prompt ensembling also we are having. What is prompt ensembling? Combining the outputs of multiple prompts. Okay, combining the output of multiple prompts. So these are some of the techniques. Okay, and drag is very important. It's a complete whole new other topic. Okay. So what it is saying? Field of prompt engineering is rapidly evolving. Continuous learning and experimentation are essential for staying ahead of a curve. So this thing is nothing but just a note, and everything is just a learning curve. So you need to follow this continuous learning and experimentation process in order to understand the things correct. So until now, prompt engineering techniques and exactly what is prompt engineering, it's clear, right? No more doubts, I guess. If anyone is having any doubts, you may ask me in the Q&A. Any doubts, anyone? Any doubts, understanding? Let me just stop my screen. Okay, now you may ask any query. I'll just share that only PPT screen. If you're asking, I mean, if you're having any query, you may ask, okay? I see no one is asking any query. Fine, we'll just proceed with this foundational models, okay? Sharing the screen. So now foundational models in AI, okay? Fine. So what is this image saying? What exactly this image is conveying? So for now we are having a data, different kinds of data, training, this is a foundation model, and adaptation, task. What are the tasks, different types of tasks we are seeing? Information extraction, object recognition, instruction following, image captioning, sentiment analysis, question answering, correct question answering. So these are different tasks, and we're having some data. How many different forms of data we are having? We're having in the text format, textual, complete textual data, and we're having some structured data, and we're having the data in the format of speech, 3D signals. Speech is nothing but audio, 3D signals, images. So these are different kinds of data. We'll just have a base model. Base model is nothing but the foundational model, okay? Foundational model. And that foundational model, if you see the workflow here, how it is happening. So whatever the data, we'll be sending the data and we'll tell the foundation, we will make sure that the foundation model is training on that particular data, and will provide or else we'll consider any one of the tasks as per that particular data. So if you consider image as a data, so we'll consider a foundation model in this image as per the task which you want. So let's say I just want to do the image caption. So the foundation model which is able to do the image captioning, I'll just make sure that this model is being trained on these images and it is able to do the image captioning. Okay. 3D signals, object recognition, information extraction, textual, structured data, question answering, speech, sentiment analysis. Correct. So different kinds of data, different kinds of tasks. Only one main thing we need to know is the foundational model related to that particular data. Okay. So just see what exactly the foundation models are. So what exactly the foundation models are? They are large scale pre-trained models that are trained on vast amounts of unlabeled data and can be adapted to a wide range of downstream tasks. They represent a shift from task-specific models to more general-purpose AI system. Try to understand the definition once. What it is saying? They are in a large-scale manner, and they were also pre-trained models. Pre-trained means the model which are already trained on the huge amount of data. Okay, so let's say if you say ChatGPT 3.5, or else let's consider the models from Meta. Okay, so Meta is having what it is. It has released different models. Let's consider Llama model. Okay, Llama is from Meta. Llama is from Meta. So in the Llama, we'll have different versions also. This in these models, we'll have 7 billion, 14 billion, 40 billion. So what is this billion, 7, 14, and 40? It is nothing but, I mean, they are parameters. Okay, parameters. 7 billion parameters model means it is having 7 billion different weights initialization and these parameters, okay, for this llama model, okay, for this llama model. So that is nothing but on all those parameters that particular model has already been trained. Okay. See, vast amount of unlabeled data and can be adapted. Adapted in the sense we can fine tune to wide range of tasks. Like here, if you see, we can consider textual data and we can consider a foundation model or else a pre-trained model, and we can do a sentiment analysis. We can do question answering. We can do instruction following. Correct. So what it is saying over here can be adapted to a wide range of downstream tasks. So by considering one single textual data, we can perform that instruction following, question answering, sentiment analysis. Correct. And what it is saying, they represent a shift from task specific models to more general purpose AI system. Okay. Task specific in the sense previously we are having T5 transformers. Okay. T5 transformers architecture. In this T5 we are having task specific. Okay. Some of the transformer models are which are related to question answering, and some are related to only language translation. Okay. So these are all the task specific. From task specific models to we are having these general purpose AI models which are able to handle all these different tasks. Okay. Fine. So what are the key characteristics? Scale. What is scale? Trained on massive data sets. Massive data sets in the sense which are of terabytes or it could be of petabytes also. Self-supervised learning. What is self-supervised learning? Primarily learn from unlabeled data using techniques like masked language modeling or contrastive learning. Okay. So whatever the unlabeled data which we are having, by using the techniques like the masked language modeling or else contrastive learning, we'll apply those kind of techniques and we'll make sure that there is some self-supervised learning happening over there. Okay. And emergent abilities. What is this? Exhibit capabilities that were not explicitly programmed. So what are the capabilities which were not have been programmed? So it will try to exhibit those kind of capabilities or else handle those things also, such as in context learning and complex reasoning. Okay. And adaptability. What is this adaptability? Can be fine-tuned or adapted to various downstream tasks with minimal task-specific data. Okay, so whatever the task which we are having, with that minimal task-specific data, we can fine-tune or adapt various downstream tasks. So let's say for the adaptability, you can consider this a textual data which has been considering a foundational model, and before it was doing only sentiment analysis, but it can be fine-tuned to do question answering, image captioning, question answering, instruction following, correct, or information extraction also. That particular model we can refine it. Okay, so those are some key characteristics. That is scale, supervised learning, self-supervised learning, emergent abilities, adaptability. Okay, these are some of the key characteristics. Okay, so there is this timeline from task specific to foundational. Okay, so how the evolution happened from the task specific models to foundational models, now we'll see. Okay, so what is the timeline? What it is saying? Early AI, traditional machine learning, deep learning, foundational models. So that is how the things have evolved. Okay, so what is this early AI? Rule based systems, expert systems, okay, which are working based on the rule based and which are expert in some of the areas. In their own areas, there were some systems which were designed to handle that particular area, I mean, or the particular domain. Okay, and there is this role based chatbots also. Regarding this chatbot evolution, we have discussed right during our NLP. When we are about to discuss NLP, we have discussed about this rule-based systems and also how the chatbots have evolved, right? That is what the timeline is. So first one is early AI, then comes the machine learning, Okay, then comes the deep learning. Then we are having the foundational models. Okay, foundational models. So we'll just go through each and every parameter now. Okay. So earlier rule-based systems and express systems, fine. We know traditional machine learning means which are task-specific models trained on labeled data. Okay. Just like DeFi transformers, which are able to handle only task summarization, or else which are able to handle only language translation. Those are task-specific models. And then comes the deep learning. In the deep learning, we are having this neural networks architecture with improved feature extraction. Okay, with improved feature extraction. Remember RNN in the deep learning, we are having RNN. Okay, recurrent neural network, sequence by sequence. Correct. But what was the issue it was having? It was having a vanishing gradient issue, and it was unable to remember the long-term dependencies. Correct. And after that, what? After that, we got LSTM into the picture. LSTM was able to remember the long term, but it was unable to understand the context. Context is nothing but the meaning of a particular paragraph. Correct. So, in order to understand the meaning of those paragraphs, what exactly the context is, here now transformers got into the picture. Okay. Transformers architecture, attention is all need. 2017, they got into the picture, and now based on that architecture only, we are having these foundational models. Okay, based on that particular architecture, we are having the foundational models, which are large scale pre-trained models with broad capabilities. Okay, so what are the key points? FMs is foundational models. Foundational models will reduce the need for task specific data and engineering. Correct. Because let's say one of my friend wants to do the summarization, one of my friend wants to do coding, one of my friend wants to do any other essay. Okay, he wants to generate an essay. So now each and every individual should go to a task specific model, right? So how the foundational models have reduced it? Foundational models have make sure that all these three things were covered under this model, So that model is able to handle the disaggregation, code generation, and also summarization. Correct. And what are the other 2 points? Enable faster development and deployment of AI solutions, increase in speed, and they facilitate transfer learning and knowledge sharing across tasks. Right. So we are also having this self-supervised learning. What is this self-supervised learning? It's like the engine behind the foundational models. So what are some techniques we are having here? BERT and Roberta. So what is BERT and Roberta? They're nothing but the masked language models. MLM is masked language models. In the masked words in the particular sentence, okay? And example were BERT and also Roberta. Okay. And casual language modeling, GPT series, all the generative pre-trained transformers, okay? What is GPT? GPT is nothing but generative pre-trained transformer again, predicting the next word in the sequence. So contrastive learning also we are having. Here we are having the examples like SIMCLR, MOCO. It's like learning representations by contrastive positive and negative examples. So whatever the positive and negative examples we are having, based on those representations, the model will be learning. Okay. So all these things are nothing but they come under self-supervised because they were learning on their own based on the data. Correct. Fine. So transformers and beyond we are having. And you all know key architecture is nothing but the transformers networks. In the transformers networks, we are having attention mechanism, multi-head attention, encoder, decoder structure. We have discussed all these things, right? Self-attention mechanism, multi-head attention, 8 multi-heads, 16 multi-heads, encoder, decoder architecture, MLPs, and in the variations, what are we having? Sparse transformers, long formers, which are designed to handle the long sequences. So they will be able to handle the long sequences in the variations. Okay. So challenges and strategies we are having. So we'll do one thing. We'll just have a short break for now, and we'll complete these challenges and strategies. Okay. So until now, if anyone is having any doubt, you may ask me in the Q&A. Okay. Please let me know in the Q&A. Anyone any doubts understood until now? I'll just keep a small poll. Okay. Let me know. And if you're having any doubts related to the topic which we have discussed until now, please let me know. Okay. Okay, fine. So I have created a small poll. Let me know through the poll. And if you're having any queries, so in the chat, you can drop the queries. Okay. So let's take a short break for now. Okay. Fine. Okay, so I hope everyone is back from the break. So where are we? We're about to discuss these challenges and the strategies, correct? So what are these different challenges and the strategy methods? First, we'll go with these challenges, and then we'll go through the strategies. Challenges. Challenges are data acquisition and pre-processing, computational resources, training stability, and also bias and fairness. What is this data acquisition and pre-processing? It is nothing but obtaining and cleaning the massive data sets. Okay, data acquisition is considering the data and pre-processing them. Okay, obtaining and cleaning the massive data sets. Computational resources. That means it requires a significant computing power like GPUs or else TPUs. Okay, why? To process all the information which you are giving or else to build a foundation model. Okay, so these are some of the challenges and strategies. But we are discussing about challenges. So one of the challenges is a computational resource. And what are the other two challenges? Training stability, bias, and fairness. Training stability. So avoiding divergence and ensuring the convergence. Okay. We need to make sure that all the foundational models, whatever the data which we are providing to that models, it should train on those models and it should not, there should not be any divergence over there. Okay. There should not be any diversion or, I mean, divergence over there. Okay. To make sure that all the foundational models are training on the data which we are having, and we need to make sure that the particular data is pre-processed or not. Okay, and there is this final challenge, that is bias and fairness. This is important. Okay, this is very important. Bias and fairness is mitigating bias present in the training data. So bias, what is bias? I'll just give an example about this bias. Okay, sorry. Oh, my screen. Okay, my screen is not being shared. But have informed me, right? Sorry. Let me just share the screen. So now everyone is able to see the screen, right? Just a moment. Just give me a minute. Okay. So now we are able to discuss bias and fairness. So, yeah. Now we will see how to mitigate the bias present in the training data. So let's say in our training data, we are having a topic that is about leadership qualities. Okay. Leadership qualities. And it is completely focusing on leadership qualities about men. The leadership qualities for men. So in this case, we can say that the particular topic is completely biased because it is considering only the leadership qualities for men. So the particular statement is biased. I mean, the particular data is biased, not the query. Okay, the particular data is biased to men. I don't want to introduce the bias in my model. I want to make sure the model is fair. Okay. So what I can do over here, this is my training data, right? So I need to make sure that whatever the leadership qualities which have been included for the men, I need to make sure that here we are also having, they are having the leadership qualities. So we need to make sure that whatever the leadership qualities we are having, just a moment. Okay, so we are discussing about this leadership qualities and how to mitigate the bias. So initially our training data is having qualities which are related to men, but we need to make sure that our data is not being biased. Correct. We need to eliminate particular bias content. So we'll introduce a new data on the same topic and we'll make sure that there is no bias in the data. So leadership qualities which are required. That's it. Okay. So I'll just show you an example. Just consider the same LLM DeepSeek. Okay. So let me just give what are the leadership qualities. Leadership qualities, but here it will just generate all the leadership qualities which are required. But we need to be very specific, right? So I'll just give leadership qualities for team leader. Okay, just give this. Let's check. Now even you can observe the reasoning also. How it is reasoning. Okay, so if you see how the model is reasoning over here, shift from previous technical AI topic, lens or prompt engineering to soft skill. The user might be preparing for a leadership role, currently leading a team, just curious about the management principles, listening in each and every possible way, and it has generated some leadership qualities. Okay, so here are the essential leadership qualities for an effective team leader, combining timeless principles with modern workplace demands: and direction, integrity, emotional intelligence, communication. So all these are some of the leadership qualities, right? So now we'll just give a biased query, like just give the same query, but I'll just introduce the bias term. So now just see the response. Actually, this kind of queries are biased. Okay, we need to mitigate the bias, but it will answer. It will answer. See the response, essential for all leaders regardless of the gender. Okay, see, bias has been not. I mean, it has considered that the bias. It is a biased query, but it has answered, right. So the bias has been mitigated in this kind of data. But if I want to know about men can lead effectively, so these are all some of the things. Okay. Fine. So that is about bias and fairness, mitigating bias present in the training data. Then we are having these strategies also. What are the strategies? Distributed training, like training models across multiple machines, mixed precision training, using lower precision arithmetic to accelerate training, gradient accumulation, and data augmentation also. So all these are some of the strategies, okay? All these are some of the strategies which will help us to improve our foundational models, okay? Fine. So training a model like GPT-3 can cost us millions of dollars in the computational resources only. Because that is one of the main challenge. If you see, there is that is one of the main challenge, computational resources. Data acquisition is also another important, another important aspect we need to consider. Okay, so benchmarks and metrics. This is important. Why? Because in machine learning, what are we having for evaluation metrics, for regression and classification? We're having different metrics, right? We're having different metrics. So in a similar way, to evaluate these LLMs also, we're having different evaluation metrics. So if you see what are these benchmarks and metrics, glue, super glue, MMLU, HellaSwag, sorry, ImageNet, and you can see the metrics. What are all the different metrics? Accuracy, one score, blue, rogue, and perplexity also we have it. So glue, super glue. Glue is nothing but general language understanding evaluation benchmark. So all these are the benchmark scores. Okay, all these are the benchmark scores which will help us to understand how the particular LLM is performing. Okay, to evaluate the LLM performance and why exactly these benchmarks or metrics are required. Because whatever the LLM which we were seeing in nowadays, we need to know in what area that particular LLM is good at. So let's consider this DeepSeek. DeepSeek is very good at doing the reasoning, correct? And in a similar way, if you consider the Gemini model, Gemini is very good at code generation, summarizing. And if you consider ChatGPT is very good at generating the long form text, right? So these benchmarks and these metrics will tell us which model is good at what, okay? So MMLU is massive multitask language understanding, which will test the knowledge across various domains. So HellaSwag we're having test the common sense reasoning. ImageNet is for vision, okay? Image classification. Metrics will consider its accuracy, F1 score, blue score, rogue, okay? And what is the main challenge here? Benchmarks may not fully capture the real world performance or specific downstream task requirements. We will just see one evaluation benchmark scores, okay? Just a moment. Okay, so if you see, there were 20 evaluation benchmarks. There were many evaluation benchmarks actually, but it is related to the particular specific type of task that you're trying to do. Okay, so if you see, just a minute. Okay, benchmarks. Not this exactly. See these, see the LLM rankings over here, best LLM core. So on the first place, we are having Gemini 2.5 Pro. We are having an O3 model, DeepSeek R1. So these are the top three for code generation. For multimodal understanding, we're having O3, Gemini 2.5 Pro again, and O4 Mini, which are from ChatGPT. And best LLM knowledge based on the GPQA. Okay? GPQA is nothing but even there were few questions. Okay, GPQA is Google Proof question answering, where we'll be having few questions which are related to completely research based. And all these models are very good at performing those research, answering those kind of questions. Okay, if you see, Gemini is over here, Claude 3.7 Sonnet, which is from Anthropic, and Grok we are having. Grok is from X, right? And we are having these long context models also. Cheapest API provider, so Deep Infra, Novita, and Lambda. Fastest API provider. So these are all different kinds of aspects, right? Yeah, MMLU leaderboard, MMLU leaderboard. MMLU is advanced version of MMLU with more complex reasoning test. So how this reasoning test will be? It will be like it will having a set of questions where those questions are completely based on choose a correct answer format. You'll be having the questions and you'll be having the options, and based on that, the LLM models will be reasoning that particular query, and they will understand that particular query and they will try to answer based on the options provided. Okay, most of the tests will be in those kind of format, and also we are having the We are having another test where it will be having all the math problems up to 8th, okay, up to 8th class, 8th standard, or 8th standard math will be having. The LLMs will be answering all the problems, okay. It will be resolving all those problems. So this is implemented is multimodal reasoning across science, math, and also humanity. And GPQA, Google Proof questions in biology, physics, and chemistry. So these are some of the benchmarks and also their scores, okay, evaluation metrics. Fine. So even in the Hugging Face also we can see this leaderboard, okay. In the Hugging Face also we can see. So I hope you understood what exactly the benchmarks and metrics were. If you're having any doubts on any benchmark scores and evaluation metrics, you may mention in the Q&A, okay. Ethical considerations and challenges. So this is another important topic again, because nowadays what is happening, we were using all the LLMs and we were providing whatever the information that we are having. Even we are uploading all the PDFs and also the charts, and we were analyzing the things, right? But will the, I mean, all those LLMs which are having our data, are those LLMs protecting our data, or else are those LLMs trying to learn on our data? We need to make sure that that is not happening, because LLM should not learn on our private data, right? Unless we are providing our data to that particular LLM, I mean, in an official way, then only the LLM should be able to learn on the data. But in this way, the LLM should not learn our data, right? Should not learn on our data. So these are all the key concerns over here: bias amplification, misinformation and deepfakes, privacy concerns, environmental impact. So just go through each and every key concerns now. So what is this bias amplification? So foundational models can amplify bias present in their training data, misinformation and deepfakes. So potential for misuse in generating the fake news and also synthetic media. And privacy concerns, the main factor. Foundational models may memorize and leak the sensitive information from the training data. Even if you observe, so whatever the conversation which you have done with ChatGPT will be storing all that memory, right? It will be storing all the conversation. So let's say nowadays, like in like a month back, there was this prompt like roast me, correct? So when you give a prompt like roast me based on my previous chart, so it will remember all the charts, correct? It will remember all those charts and it will be roasting you according to the particular queries which you are asking, correct? So from that roast, are you sure that those LLMs were not learning on your data? So that is another important factor to consider, right? So that comes under one of the privacy concern. So environmental impact. Training large models consume significant energy. Correct. So mitigation strategies. What are some mitigation strategies and how we can mitigate from them? So data auditing, bias mitigation techniques, watermarking and content and also differential privacy and federated learning. We're having energy efficient model design. Energy efficient model design is nothing but models which are not consuming much of the computational resources. Okay, so these are some of the mitigation strategies and key concerns. Natural language processing applications we're having. So everyone understood, right, about these ethical consideration and challenges and also benchmarks and metrics. Any doubts, anyone? No one is any doubts. Fine. Let's proceed. Okay. Natural language processing and applications. Okay, here we are having text generation, machine translation, question answering, text summarization, sentiment analysis. All these applications are discussed when we were going through NLP, right? When we are about to discuss NLP, all the 7 layers we have discussed, all these applications we have discussed, and also we have gone through tokenization, correct? Tokenization and also what exactly the NER is, named entity recognition, POS tags, correct? So we'll just go through the examples. Text generation examples are Jasper AI. It's nothing but a content generation platform powered by GPT-3. And we have this machine translation where there is this DeepL, which will do a translation service known for its high accuracy also, real-time translation, which is multilingual, question answering, like search engines, virtual assistants, examples like Google Lambda. Google's Lambda is an old model, okay? It's an old model. Upon this Lambda only, we got Gemini models, okay? Upon this Lambda only, we got Google Bard. Remember BARD. And after this Google Bard model, we are having this Gemini models, okay? Gemini Flash, all these models. From the Lambda, we got Bard, and then we got Gemini So text summarization, you all know. Sentiment analysis, which is completely related. It could be related to the language to another language. Smart assistant, document analysis, online search, predictive text, automatic summarization, social media monitoring, chatbots, sentiment analysis, and email filtering. So these are some of the NLP applications only, okay? All these applications which you're seeing on all these functionalities, if you're seeing on any of the application, so that means it could have been built by using the NLP, okay? So computer vision applications. So understood NLP applications. Everyone remembers the NLP, right? Tokenization, stemming, lemmatization, spacey. If you're having any queries about those applications, so you may ask me in the chat box, okay? In the Q&A, you can ask me the query. So now we have this computer vision applications. So what exactly these applications are, we'll just go through. So image recognition and classification, like object detection, image tagging. Example is image recognition in self-driving cars. So the best example you can consider is Tesla. Correct. And image generation is nothing but DALI. DALI is a model from ChatGPT, right? Image generation model. And Midjourney also we're having. And also we are having a few other image generation models, stable diffusion models, okay? Which will work based on text to image. And we can also make sure that it is working from audio to image, okay? Audio to image. Image editing and manipulation, like removing objects, changing styles. So Adobe's Photoshop AI powered editing tools, like Adobe is also having this Fireflies, okay? And video analysis, all these kind of applications where you are seeing the object tracking and activity recognition. See, if you see this video analysis, one example I can give, that is online proctoring we have, right? Online proctoring, online exam if you are writing, if you just turn our head a little bit. So the box where it is showing where our front cam is activated, and over there you can see the box turning into red and you will be getting a warning, right? So that kind of analysis or else object tracking, activity recognition is happening through computer vision only, okay? So now computer vision applications we are done. We just go through this multimodal applications, okay? So what are the multimodal applications? Question answering questions about the images, asking what the person is doing about the photo. Image captioning, generating the descriptive captions for images. Example is automatically generating descriptions for images on social media. Text to text video generation. Text to text video generation is creating a short video from text prompts. robotics. How it is helpful in robotics? The foundational models can enable the robots to understand and also interact with the world in a more natural way. See the example, robotics using model to complete the complex task. So for this robotics, if you want to see an application, you can refer to Boston Dynamics, okay? Boston Dynamics, you can refer to this company. You can see how they're working on the robots and how the robots were able to do the complex task, okay? Okay, applications of LLMs. Just go through these applications of LLMs once. So what are the applications of multimodal large language models? So web development, game development, educational assistance, medical diagnostics, content generation, business analytics, security and surveillance, e-commerce, industrial applications, image captioning, virtual question answering, and virtual personal assistants also. So how these multimodal large language models can be used in e-commerce? How it can be used in e-commerce? So e-commerce, let's consider Myntra, okay? Let's consider Myntra. So in Myntra, so we'll be doing all the shopping through all these e-commerce applications, right? So let me just consider Myntra for now for the example, how it is helpful for multimodal LLMs. So in Myntra, there was an update previously, like how it works is, if you just give the text, okay, give the text like, you just mention a check shirt with red and black checks. So let's consider that as an example. So you're just giving an input like red and black check shirt, and it will give all the similar search results, correct? So that is working based on the text, right? Based on the text. And the other way is you can describe the text also. You can describe the text also. Okay, you can describe the text based on the description. Based on the description, it will give a similar kind of products. Okay, just like let's say you have seen a blue jeans with some completely faded. Okay, so now you can give a description, completely blue faded jeans, and you can give your waist size over there. It will give a similar result. So what are you doing over there? You are giving a complete description. Okay, you are giving a complete expected output, and you are telling that so to give the similar expected result. So Myntra is able to do this reasoning. Okay, Myntra is able to do in Myntra in the search bar they have implemented it. You just need to give in the prompt, and it will just give the similar search results. Okay, once try that. Okay, and content generation you all know nowadays in any of the LLMs we can do the content generation. Like it could be image, it could be text. Correct. Industrial applications. Industrial applications will completely again divided into domains. Okay, based on the domains will work. Image captioning is nothing but what of the image that you are uploading can that particular image. So now the LLM is able to understand that image, and also it will generate the output in the format of text. So that is why we are calling it as a multimodal large language. Large language models are of three types, right? Text, audio, and image. So text to text model, text to image, audio to image, or text to video we can say, image to video we are having. So it is handling two different tasks over there, correct? Image and also text. So in the medical diagnostics also, one of the applications we can consider is nowadays in radiology or else in any other lab, we can see like it is able to understand the scan report and it is able to analyze the disease and it is telling what kind of disease the particular person is exactly having, right? So that is one of the application in the medical, okay, in the medical field. So these are some of the applications, okay. Okay. So now moving into, so if you see drug discovery, predicting drug interactions and identifying the potential chemical compounds, that is improving the accuracy of the climate predictions. Example like analyzing the model to simulate and predict the climate changes. See, we are already seeing this climate modeling, and also we are having genomics, which will help us to identify the disease-causing genes and developing personalized treatments. So all these the scientific discovery and research in these areas, in these particular domains also, the LLMs were able to perform well. Okay. So just go through this idea generation, experiment iteration, paper writer, idea plan innovation, novelty check, scoring, experimenting, updating the plan, template, text LLM and the manuscript again, and the paper reviewing. So if you see the workflow over here, how it is starting? It is starting from an idea. So whatever the idea that you're having, you will just that to LLM and you'll try to get more insights from that idea. And there is this experiment template, and also, I mean, you need to create an experiment template if you want to work on that particular idea, update your plans accordingly by considering all the insights that LLM is providing. That is nothing but iteration, right? Based on the iteration, if you want to go through again the LLM and again you can go through that particular LLM, review the things, and if you feel like there is something wrong, you can refine that particular prompt or else refine the idea or else refine the insights, refine the functionalities, and again you can just go through the ideas, okay? Experiment iteration, paper write-ups, and idea generation. This is just the workflow. If you see in between experiments and updating the plan, only the iterations are happening. Okay. Okay. So we'll just complete this future of foundational models. Okay. So what is the future of foundational models? Key trends and also potential impact. What are some key trends over here? Larger models, more foundational models, improved reasoning, personalization, and edge deployment. So what are these larger models? Models will continue to grow in size and complexity. So models will continue to grow in size. So nowadays we are having small large language models, okay, small models. That is like from Microsoft we are having a pi model, pi, okay, which is trained on only 1.5 million, okay, 1.5 million parameters. And from Google we are having a gamma model, okay, gamma, which is 9 billion parameter model, okay. And also exactly in the quite other end we are having a huge billion parameter models from NVIDIA. Only we are having a model called Megatron, which is having around 500 or else 600 billion parameters. Okay, Megatron model is built on around 600 billion parameters. And the foundation models will also integrate even more all these modularities like sensor data, 3D models like object detection, improving the reasoning. Like all the foundational models will exhibit more sophisticated reasoning and problem solving abilities. See, initially in around 2022, we're just having ChatGPT, which was able to answer all the queries. Okay. But if you see right now, we're having this DeepSeek also. DeepSeek was able to do the reasoning. And from this DeepSeek only, even in the ChatGPT, we are able to see the option called as research. All those filter options we are having. And personalization, HDL, H deployment, potential impact. Potential impact is models will transform nearly every industry aspect of our life. So we have already we are already seeing this, correct? We're already seeing this. How it is impacting in our day-to-day life, correct? How the models are impacting our day-to-day life. We are already seeing that, right? Okay, so these are some of the key and potential impact. Okay. So resources, we just go through resources also. So some of the resources are Hugging Face. We have gone through the Hugging Face, right? We have explored it. We have explored also different modules. We have platforms like again, AWS, Azure, GCP, from Oracle also we are having. All these models, they are offering pre-trained foundational models and infrastructure for training your own application or for training your own data. If you see, IBM is having what IBM is having their own models, right? What are those called as IBM models? We are having IBM 13 billion parameter model. In AWS also we are having some models and they were settled in the Bedrock. Okay, in the Bedrock we'll have some models. In GCP is nothing but it is from Google. So we are having this Gemini different versions. We are having 2.0, 2.5 versions. So these are all the resources where we can find all those foundational models. Okay. Okay, this is it for today, guys. So if you're having any queries for today in this session or else any queries related to any other previous sessions, you may post it in Q&A. Okay. Yeah, please let me know whatever the query that you are having. So related to project in your upcoming AMA session, we'll be briefing you. Okay. So as this is our last week, so we'll be also implementing one of the IBM model. Okay, from Hugging Face, we'll be considering one of the IBM model, and we'll be implementing that model. Okay. And projects will be related to the use cases. Okay, the use cases just like you can consider like the customer analytics or else any text to text generation or else text to image generation. Those kind of use cases you will be seeing. Okay. I hope it's clear. If you're still having any doubt, let me know. I hope it's clear. And don't worry about this project, okay? We'll be explaining how to exactly understand the project and how the project file the structure needs to be. How can you use different models? Okay. So is it clear? Thank you. So I see if no one is having any other queries, this is it for today. So you may leave the session. Thank you. And also one more thing, I see a few people have not attempted the quiz, it seems. So please attend the quiz, okay? Everyone, please make sure that please attempt all the quiz, okay? Thank you. I will be ending the session now. Thank you, guys.